Hi guys, now we'll see today's lead code problem, which is partition array according to given pivot. So this question we'll solve using two approach. One like direct brute force and other is a bit space optimized approach. So here we are given a zero indexed integer array whose name is nums and an integer pivot. Now we want to rearrange the elements in nums such that the following conditions are satisfied. So we want every element which is less than pivot should appear before every element that is greater than pivot, and every element which is equal to pivot should appear between the elements which is less than and greater than pivot. And the relative order of the elements less than pivot and the elements greater than pivot is maintained. That means like if before arranging the elements are at index I and j, ij and I is less than j. So if they are rearranged to new index pi and pj, so pi should also be less than pj. Like here if we see 9 is less than 10, so this should come before 10, and 5 is also less than 10, so we want to put them before 10, but their relative order should be like maintained. So we'll see example to understand this question in a better way. So like here, this is the nums array. These elements are given, and this is the pivot. So we want that first all the elements which are smaller than this pivot should be there. So 9 is there, then 5, then 3, then all the less than elements are done. Then we'll put all the equal to elements like 2, 10 are there that we have put, then all the greater elements 12, 14, but their relative order is always maintained, like 9 comes before 5, so in this also 9 should come before 5. So brute force approach we'll see. Brute force approach is very easy. We'll take three vectors. In one vector we'll store all the elements which are less than pivot, in other which are equal to pivot, and in the third which are greater than pivot. After that we have all the three vectors filled. We'll take one resultant array. In that we'll first put all the elements which are in less vector, after that equal, and then greater, and then return that answer. Like we'll see code to understand that this approach in a better way. So like here we have taken three vectors. One is less, second is equal, and greater. We are simply traversing in this nums array, and we are checking if this number is less than pivot. We are pushing that in less vector. If it is equal to pivot, then equal. If it is greater, then greater. After that we got this less than pivot elements equal greater. So now we are just trying to put those in our resultant vector. Like here I have reused this nums only, but if in the question it is written that we can't use nums, or ideally we should not use nums because we are changing the input, you can take a resultant array also. So first we are trying to fill at index 0. So first we'll fill all the elements which are present in the less array. So we are just traversing the elements in the array, and we are filling the nums array. Once less elements are filled, then we are filling the equal elements. Once equal are filled, then we are filling the greater elements, and after that all the elements are filled, then we are returning the nums. Here if we see like time complexity, then it is big O of n only, and space complexity also, it is like kind of big O of n only, but three vectors like we are taking. So like we'll see a bit optimized approach. Here what we'll do, we'll traverse in the nums array from left side, and we'll start putting all the less than elements from the left side in resultant array. Like if the number has like this 9, 12, 5, so first we'll traverse from the left side, and since this element is less than 10, so in the result array we'll put 9 in the leftmost at 0 index. Then we got 5 that we'll put at 1 index. Then we got 3 that we'll put at 2 index. then we'll traverse from right side and start putting all the greater elements at the right side of the like resultant array. So then we'll traverse from right side. So we got 10, this is equal, we want to put only greater element, so we'll skip this also. Then 14 is greater than 10, so result of n minus 1 we'll put 14. Then we got 12, n minus 2 we'll put this 12. After that, the left indices we'll fill with pivot. So leftover indices we have filled with pivot. Like we'll see the code to understand this in a better way. So here like we have taken a resultant array, and initially we are traversing from left side and we are seeing if any element is less than pivot, then we are putting that element in the result. Once all the indices are, all the iterations are done, then all the less than elements we have put in the leftmost side of the resultant array. Then we are traversing from right side, and if any element is greater than pivot, we are putting in at the rightmost side of that like array. And then we are starting from n minus 1 and we are doing right minus minus, so that it moves left. When all the iterations are done, then all the greater elements also filled. Now only from left to right indices the elements are left. So until left is less than equal to right, we are just filling those positions with pivot, and after that we are returning the result. In this, like we don't need the extra arrays like which we are taking less than, greater than, and equal to three vectors we were taking, that we don't know, that we don't need. And anyhow, like in last approach also, resultant vector, so we need to return also, so that was needed only. We were just using nums, which is not a good practice, because we should not change the input until and unless it is mentioned in the question that you can change, use the input array only. Now we can observe one thing in this, like first we are going from 0 to n, then we are going n minus 1 to 0. This we can do in one loop only, because when I is equal to 0 represent the first element from left, so n minus 1 will represent the first element from last, which we can simply write by n minus 1 minus I. So like we'll see this approach. So here, instead of using two loops, I have just used one loop only. This is simply like we are traversing from left to right, but for right also we can simply, like instead of going from another loop, we can just replace this index by n minus 1 minus I. Then it is it's equal to similar to traversing from right side. So same thing, instead of using two loops, I have used one loop only. So in this, we are filling the left side with the elements that are less than pivot, right side with the elements which are greater than pivot. After that, from left to right indices which were left, that we are filling with pivot and returning the result. If we see time complexity, it is big O of n, and if we see space complexity, only this vector like we are using, so you can say big O of n.